Thank you for joining us at the Palais de Expositions. A big conference center of the United Nations Conference of the Oceans, which are playing an important big role in our climate system. Hey, and we need this Earth, including the oceans, to live. So we have to deal with that, and there's a lot to discover. Still, that's what Bernadette once told me. We don't know everything, but it doesn't mean we don't know nothing. Yes, I remember that one. That's a good one. We don't know everything, but it doesn't mean that we don't know nothing. All right, we had 4 sessions this morning, 4 interesting sessions. And people came to me and said, it could have been longer. Yes, we know, but we want to make you curious. And when you are curious, that's a good thing. When you start falling asleep, that's a bad thing. What's okay? I'm starting already. I'm not a stand-up comedian. I'm supposed just to moderate something like this. I already started. Okay, take a place. We had 4 interesting sessions. I hope you had a nice comida, le déjeuner, mittagessen, il pranzo. So don't fall asleep. Just keep your brain awake. We have some younger generations nearby. That's also good. Session number 5 is about changes in the ocean monitored from space. We're going to see some examples from the ESA Climate Change Initiative. And someone who can talk about this is the head of ESA Earth Observation System Architect's Office. That's a mouthful. But he knows a lot, and that's what I like. From the ESA, Mr. Craig DONLON. I'm so sorry, it's like, okay, head of the ESA Earth Observation System Architecture Office. What do you tell on a birthday story what you do for a job?
My job is manyfold, but essentially what we're looking at is the next generation of satellite data sets that we need. And then we design and build spacecraft together with EUMETSAT and the European Commission to provide the observations to look at our ocean.
And then they still talk to you at birthday parties, or?
Oh yeah, they still talk to me at birthday parties.
Okay, no, that's good, because how do you, it's an interesting job. I know, I love satellites. Not only from our profession, but I love them.
No, they're wonderful.
We are the age that we had a print on the wall. No digital age, print on the wall with satellite images.
Yeah.
We're that old. I love to listen to all your experts. Please go ahead.
Thank you. Well, first of all, it's all about satellites, but satellites are only as good as the people that use them. So I'd like to show a small movie of the work we've done in the last 46 days as we journeyed from Tromsø down to Nice.
My name is Dr.
40
Craig DONLON,
new ambassadors.
and I'm the leader of the European Space Agency Advanced Ocean Training Course 2025 aboard the tall ship Stadscat Lemko. I work at ESTEC, the European Space and Technology Research Centre in the Netherlands, where I am responsible for the future missions architecture. And my job here is to bring the best out of the students that we're training on this historical tall ship. The oceans are fundamental to life on this planet Earth. The European Space Agency, together with the European Commission, has built a whole series of different satellite instruments that flying in space today that provide unprecedented views of the oceans from space. Because what's important for us is to be able to connect what is going on in the deeper ocean with the surface measurements that we make from space. But satellite data and measurements from ships are not enough. We need to make sure that we have the people that are able to interpret and work with those data for applications that underpin policies, that create jobs, that lead to new insights into the way we can have a sustainable ocean and a sustainable future. Without those students being challenged and being trained, we cannot hope to make progress of interpretation of satellite data. It is a wonderful place to train our next generation of ocean scientists to ensure that we understand what the blue of our planet ocean really is all about. Because without blue, there can be no green.
Several of the students on board the ship are in the audience if you want to talk to them. Yeah, they're just over here.
Where are the students? Hands up. Thank you.
So call them out. So my real talk now is to remind ourselves of the beauty of the oceans from space. From space, we see the very surface of the ocean. It's difficult to see inside the ocean, which is why we need the ships, the Argo floats, many other gliders, and the operational in-situ oceanography system we have today to interpret what we get from space. This is really the remit of what the European Space Agency has been doing for the last 15 years, which is to bring all of the satellite data sets together so that we can actually homogenize them, ensure their calibrations are very, very good, and make sure that we can bring a new set of data that allows us to look and interpret what's going on in our ocean from a purely data-driven perspective. The system is complex. It has many different parts to it. What I'm talking about today is the ocean part, so the salinity, the sea state, sea ice, and sea level, plus ocean color. It's ocean color radiometry from which we can work to look at ocean biogeochemistry. And there are many, many different data sets that we can make from space. These are almost like your spectacles or your sunglasses. We look at the Earth with different lenses, with different ways, yet we see the same features. So we might be using the visible spectrum, we might be using radar, we might be using LiDARs. All of these data sets tell the same story. Our ocean is in measurable decline. And I repeat, our ocean is in measurable decline. We can measure that from space. It is unequivocal. Some of the data sets are more easily accessible than others to all of us. For example, we can look at gridded data sets globally. We are working with global coverage data. Space gives you that unique opportunity. We'd need billions and billions of ships at sea to make the same measurements that a satellite can make in just one day. It's quite phenomenal. We have data sets that are verified and validated by ships and other means at sea, so we're confident in the performance of these data. We have uncertainty characterization, so we can actually quantify how sure we are of the conclusions we draw when using satellite data sets. And we have many peer-reviewed papers that justify the work we're doing. And that is the scientific method. We need that to make sure we have credibility. As a classic example, you may have seen this curve several times. Here's another version of that curve, produced together with our colleagues at EUMETSAT. And this is the record of sea level rise from satellite data. There are no model data and no in-situ data used in this time series. And it uses many different satellite data sets that all have slightly different features. And it's a bit like us. We are male and female. We have two different model numbers, but many, many, many different chassis numbers. And our satellite systems are a bit like that. We're using the same principles, but they're slightly different each time. And we need to take care of that by analysis of the data, by scrutinizing the performance of the measurements, and continually monitoring that so we don't make an error. Because a small error in a satellite data set is a big error for everybody else, simply because there is so much satellite data out there. But you can see there is consistency between the different satellite data sets. And not only that, we have several new satellites ready for launch that will continue this record way into the 2030s and up to 2040. And that is important because it takes quite a while to build a satellite, roughly around about 10 years. So we need to prepare now. What the data tell us is, of course, that sea level is indeed rising, but it's rising for a number of different reasons. And by using different satellite data sets together, we can look to understand why we have regional variability in sea level rise. We have to consider the ocean circulation. We have to consider post-glacial rebound from the last ice age as the land is continually uplifting. We have to look at the gravitational adjustments due to the loss of sea ice and changes in the average winds and sea state. All of these complicate the preparation and interpretation of these data. Yet that's the job of the ocean scientists. Also, the contributions to sea level rise have changed quite dramatically. Today, it is ice loss that really makes the big contribution to our sea level rise. Thermal expansion is a close second, and everything else, including extraction from water in our subterranean reservoirs, is a close third. Again, all of these things conspire to complicate the data sets that we bring to you for use and interpretation. In terms of sea level budget, we want to understand how we can close the budget between different aspects. So the thermal expansion of seawater is one component, and the land ice melt and water storage is a second one. And we can measure that from GRACE gravity missions. The data sets that we produce actually hold together very, very well. And they bring an independent set of measurements that allow us to be confident in what we're looking at in terms of closing this sea level budget. And that means that we have a good understanding of what's going on. And sea level is important not only in a global context, but where does the water lap up against the shore? Because that's what really matters to people. And communication is all about making sure that people are safe, making sure that people have the right information. And so when we start to look around the coasts of the world, we see that some coasts are more integrated than others. And it's a big deal for us. Okay. Sea surface temperature, many of you seen from space, but creating the perfect animations of this is difficult. You can see the static data on one side. It tells one story, but when you animate this, it's much more powerful. And likewise for ocean salinity, a new measurement from space using microwave radiometer techniques, which are very important. These will be taken forward by a new generation of missions. And of course, when you start to look at the time series of data, which is what the climate change initiative is all about, you can see fingerprints of different signals with precursors, allowing us to improve our predictions of El Niño and La Niña. Ocean color radiometry gives us this unique picture of oceans from space. When the first SeaWift satellite was launched many years ago, it was very, very important to understand what the hell was going on. We could see anticyclones and cyclones with biology and without biology in space for the first time. It was a revolution. Yet today we can produce amazing monthly means of the data sets. Also changes in the storminess of our planet, and this is created from a set of radar altimeters, and including an Envisat, Cryosat, the Jason series, and the Sentinel-3 series. This is the mean significant wave height, so it's kind of like the top 1/3 of waves. There's another third high again waves to add on top of this, so this is a stormy sea. And by looking at the time series, you can compare what was going on in the 2010s to the 1990s. And we can see an increase in many areas of the roughness and the waves on the ocean surface. All of these things conspire together. And of course, we can use these to understand what is going on in a controlled manner. This is the kind of strategy that we have, bringing different data sets together to support the IPCC, for example, and also the work of UNOC here today. So with that, I think I'm just about on time, and I bring it back to you.
Yeah, no, you're perfectly on time. Any questions? Well, if you have a good story, I hardly dare to interrupt. It's like, oh, I could listen for this for 10 more minutes. I got 3 more minutes, 10 more minutes. Any questions?
Hello, Raquel from Mexico. We are living now Niña, or we are a transition. What's happening now in our ocean?
So our ocean is continually changing. And I'm not sure, actually, if we're in Nina or Nina at the moment. I think we're what's called static. So we're waiting. And of course, our models are being used, and our satellite data sets are there to give the precursors and the right signals. And particularly salinity gives a precursor of around about 2 to 3 months. So when we start to see changes in the salinity and the sea surface temperature, that is the kickstart for an El Niño signal. So that's been monitored by many agencies around the world, and the data sets are published regularly.
You can find somewhere what the state is right now.
Absolutely.
It's a light La Niña, but not a real La Niña. But the tropical people probably know as well. to find it, go to Ariel. He can give you the website. Or Ada. Oh, Brigitte, WMO, Brigitte. Brigitte? Neutral, it's completely neutral. Okay, it's neutral.
Absolutely neutral.
Thank you. I have a question regarding the salinity. How can you measure the salinity from the space? And how sensitive is this measure?
Okay, we measure the salinity for space in the L-band frequency, which is about 1.42 gigahertz in frequency. There is sensitivity there that is at least good enough to do good measurements in the tropical and warm oceans. As you get closer to the coals, that sensitivity decreases because the dielectric constant is affected by the cold water. The way around that is to produce instruments that have a better sensitivity. So for a radiometer, a microwave radiometer, the next generation we're working on right now, called the Copernicus Imaging Microwave Radiometer, has a sensitivity of 0.3 Kelvin, and that's easily sufficient to do a good job in the polar regions.
You believe him? They're doing a good job. I got a question. Are these images freely available?
Everything from the Climate Change Initiative is freely available. In fact, all data sets from the European Space Agency are freely available to anyone. Within the Copernicus program, that is also true. And so there's nothing stopping everyone making the most of the data sets that are created by your space agency. The European Space Agency and EUMETSAT are there for you. They're not for us. Every taxpayer in Europe pays for these, and you're entitled to use all the data that you wish.
And we do
Please
pay a lot of taxes, so...
You do, but you spend it well with EUMETSAT, ESA, and in the European Commission.
Well, and don't mind to give credits to them, so other people can also search for images. That's always a good thing. Yeah? Thanks to ESA, we got this image.
Yeah, I mean, it's not just the images, it's the digital data that underpins the image, which is important. These are scientific measurements. Every single dot that you see on the screen is a scientific measurement.
But that's a good point.
Just as it's made in a laboratory, except our laboratory is in space.
Okay, that's a good point, but scientists do understand that there's a whole world behind it.
Yeah.
But we communicate with a big audience. They don't get a clue. So help us understand to communicate it.
That's why we're using animations. That's why we're making short films. That's why we're training our next generation of ocean scientists to communicate. A scientist is only as good as the communication that they can deliver, be that in a journal article, a newspaper
but you can't have
or
it all.
standing here.
Not every meteorologist is a good presenter. Not every good presenter has any knowledge of something. So.
But then that's their management should send them on training courses to be so. Otherwise, they're not good enough.
I will. Thank you. You speak Dutch as well. You live in the Netherlands.
Iets smakelijk.
Dankjewel voor jouw bijdrage. Thank you very much for your... Thank you. Craig DONLON.